Welcome to lesson 31, domain and range in real world applications. So basically, we're going to look at more word problems. Here are the 3 things to look for while I'm modeling and for you to practice and get feedback on before your end of class assessment. So number 1, that you can identify which part of the word problem represents the domain or the input and what represents the range or the output. That way you can tell which are going to be your Y's and your X's in the problem. Secondly, can you just figure out what the problem is asking for? Do you understand the question and the context of the problem? And third, we're going to use definitions of subsets of real number systems because many of the problems we have today, we're going to have to define what kinds of numbers we would use in the domain and range. All right, so we're going to do some real talk about some real numbers. And this was something you may have touched on in 7th grade, but it's a lot of vocab. But it's going to be really important for this section on Regents questions and on the practice we're doing today. We're going to start with the first level, which are natural numbers. And these are sometimes called counting numbers. And think about when you were little, you would get like a bin of little colorful bears or tiles, and you learned to count things. You would count items starting from 1 until you finish the set. And you would learn that you could never get to the end because that's infinity. You can count forever. And that's what natural numbers are. Starting from 1, they go all the way to infinity. So that's our first set of numbers. Then we progress to whole numbers, and whole numbers are pretty much all natural numbers plus 0. That's it. That's really the only difference, is everything in there from 1 all the way to infinity and 0, and that the importance of what 0 can do and what it means. And notice when you got a little older, you started talking about 0. Then by about middle school, you start to talk about integers. And integers are all the whole numbers, so from 0 to infinity, all the way to infinity, and are negative whole numbers. So we have whole numbers plus negative numbers. So you can see how our definition expands to more and more types of numbers. So we're moving on with these, and we get to integers, and integers are great because now we can work with what does a negative mean and what does it mean in the context of a problem. Then by 7th grade, you did a lot of work with rational numbers, and these were all our fractions and decimals. And that was real important because we realized that we can have parts of numbers. And if we only stuck with integers and whole numbers and natural numbers, there would be a whole lot of mathematical thinking we wouldn't be able to do. It would be a little more challenging. So the idea of rational numbers is awesome because we can just do so much with them. Now, so you can set the stage. These are the terms you're going to see a lot in our multiple choice, where they're going to ask what can represent the range or domain, what kinds of numbers make the most sense for the type of problem we have. But there's one more set that is not here on this list. So I'm going to put a little star here on the bottom, and these are irrational numbers. And they are real numbers as well. And those are, we've been doing a lot of stuff like when we've been doing things like square root 2 or negative square root 2, or how about pi? These are real numbers as well that we sometimes work with. Or if we have a decimal that just never ends, it just goes on and is non-repeating. So if I had like 3.142895596 and it just went on and on and on, that happens too in math. We sometimes have non-repeating, non-terminating decimals, and those are also real numbers, and they are in the irrational pile. So we're going to talk about how to use these types of terms when we're talking about domain and range. And so it matters what the context of the problem is, because some contexts you can use a whole number, some you can't. So let's look at this first problem over here. A manager wanted to analyze the online shoe sales for his business. He collected data for the number of pairs of shoes sold each hour over a 14-hour period. He created a graph to model the data as shown below. The manager believes the set of integers would be the most appropriate domain for this model. Explain why he is incorrect. All right, so first things first, you remember your domain were your input numbers. So they're down here. This is the domain. And in this case, it's time in hours. And the manager thinks we can only use integers for this problem. So pretty much positive and negative numbers and 0. So is he correct? So let's think about this. I can see that because it includes natural and because it includes whole and integers, we have a large set of numbers. But what about rational numbers? Think about time, for example. Could we talk about how many shoes sold in half an hour? Yeah, we can. And because half of an hour, 30 minutes, half of an hour is rational, his definition is incomplete. So let's put that in. The mayor is incorrect. Because the context of the problem can include rational numbers for time. I want to make sure I have this looking neat. Such as 1/2 hour, period. So I'm gonna just hit pause right there, and you can see that's what would make this incorrect. Because if we were talking about minutes, if we wanted to have an understanding of how many pairs of shoes were sold after a certain set of minutes, that is a time interval that can be measured in the context of this problem. So hit pause and jot this down. And you can see how these terms are going to be important. So I'm going to leave that little image in the corner of some of the work, and it's also in the front of your notes if you need to go back and forth as you're doing problems. So here's one that you could also try out. So if you'd love to, you can hit pause and try and solve it, figure out what the answer is before I go over it. I'll give you a second before we do a review. Okay. So let's look first at the context of the problem. Which number best defines the domain? Of course, this means our x values. And here we have x as the number of complete products sold. So if x equals complete products sold. So that means I'm going to eliminate positive rational numbers. That doesn't make the most sense in the context of this problem because these are completed products, and we're not going to talk about if half of a product was sold in the context of this problem. Now, what about, let's look at integers. Could you have negative items sold? So no, that's also not going to make sense. So I can't have x is equal to -8. -8 would mean -8 items were completed and sold. So that wouldn't make any sense. So I'm going to put that in there. X equals -8. So if x equals -8, this wouldn't make sense. So -8 items sold. And the same thing with rational numbers. If x was 3/4, again, would make sense. We wouldn't talk about 3/4 of an item sold. So now we have two. We have positive real numbers and we have whole numbers. But remember, we also have another set of real numbers in here, which would be our irrational numbers. So when we say positive real numbers, we're saying anything positive in this whole group. And that just doesn't make sense. So we cannot have irrational numbers. that doesn't make sense. Wouldn't count this one. So the best choice in this option would be whole numbers, because we can talk about the whole number of items that are actually completed. That makes the most sense in the context. So you can see a little bit, see if that matched your answer. If you had something different or you were unsure, you can change it now. But that is the context of today's work. We're trying to identify what they're trying to ask us for, what is the domain, what is the range. In a lot of problems, they're going to tell you which one it is. Or if you have a graph, like here, you can see what the domain is and what the range is. Okay, and if they don't tell you, then figure out which is the first item, like what's the input that starts the problem, and then what is the output, what is the outcome. That could help you. We can figure out what the problem's asking us to do, and then try and use our subsets of number systems to decide what most appropriately represents the set of numbers. So this is just honestly going to take practice. There's a lot of terminology as you're building meaning and understanding. So don't be afraid to look back and forth at your list, to ask questions, to say what makes sense to you, and to really push yourself when things don't make sense. Talk it out, or talk it out with another person and get that feedback. That's it for today, Math Marbles. I will see you in the next lesson. Be well.